Hi everyone, welcome to lesson 1.3. This lesson is on converting to factored form now. So we just saw how to convert to general form, now we're going to convert to factored form. Okay, and basically what we're doing when we're converting to factored form is we're trying to defoil. Our last lesson was on using FOIL to multiply things out. We want to now do that in reverse. We want to defoil it and go back to those sets of parentheses. Okay, so here are the steps. We know that our factored form needs to look like this, right? We have two sets of parentheses that are the factors, and the first terms in those parentheses have to multiply to x squared, right? We multiply the first terms, x times x, we need to get x squared. Then we need to find what two numbers go here and here. And those two numbers, so when I do the outer and the inner, I'm going to add them together when I combine terms, and when I add them, I need to get 8. When I'm combining terms, I need to get 8. So I know I need two numbers that are going to add to 8, and then when I do the last terms, I multiply those two numbers, I need to get negative 20. So they need to multiply to negative 20. So here's what we do. We start by finding the two numbers all the numbers that are going to multiply to negative 20, and then we'll find a pair that can make 8. So we're going to list all the factor pairs of the constant term, which is this last number right here. So let's list the factors of 20. And don't include the negative in this phase. The negative will happen naturally when we make 8. So factors of 20, just start with 1. So 1 and 20, then 2 and 10. There's no pair for 3, that doesn't divide 20 nicely, but 4 matches with 5. And then I'm done because the next number would be 5 and we already have that. Okay, so now we're looking for a pair. We're going to find the pair that can add to the coefficient of x, which is this middle number, or the 8 there. And keep in mind that we may need to use negatives. So 1 and 20, I can't make 8 out of 1 and 20. But 2 and 10 can make 8. So if I do a negative 2 and a positive 10, I get an 8. So that's telling me the numbers in the factors should be negative 2 and positive 10. And it doesn't matter where they go, so I can put the negative 2 here and the positive 10 here. I could have also flipped them and it would still be fine. And now we're in factored form. And we could quick check our answer by doing a little FOIL in our head. So x times x is x squared. We would get 10x minus 2x, that gives us 8x, and then minus 2 times 10 gives us the minus 20. So we did it right. All right, let's do some more examples of factoring. Okay, x squared plus 11x plus 18. So we know that our factors need to look like this. And we want to find the two numbers that go in the factors. And those two numbers need to add to 11 and multiply to 18. So we're going to list our factor pairs of 18. 1 and 18, 2 and 9, 3 and 6. There's none for 4, there's none for 5, and then we're back to 6. Okay, so now we're going to go down our list and look for a pair that could somehow make 11. We might need to use negatives, we might not. So 1 and 18, I can't make 11 out of 1 and 18. 2 and 9, though, I can totally make 11 out of 2 and 9. So if I do positive 2 plus 9, I get 11. So that's telling me that the numbers in the factors should be positive 2 and positive 9, and it doesn't matter where they go. So plus 9, plus 2, and we got it. We're now in factored form. And we can also say now what the roots are, right? We can read the roots off. Those are the numbers in the factors, but we remember to flip the signs because they're x values. So the roots would be negative 9 and negative 2. All right, another example. Start by setting up our factors, x and x. We know that we need to add to 9, multiply to negative 36. So let's list our factors of 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. If you're not sure what the factors of a number are, you could just do 36 divided by 2, and you'll get 18, so you know 2 and 18. 36 divided by 3 gives you 12, so 3 and 12. 36 divided by 4 gives you 9, so 4 and 9. Okay, so now we're going to go down the list and look for a pair that could make 9. We might need to use negatives. So 1 and 36 isn't going to work, 2 and 18 can't make 9, but 3 and 12 can. If I use a -3 and a +12, I get 9. So the numbers in my factors need to be a -3 and a +12. All right, and we're in factored form. And then let's just say what the roots are. We flip the signs, so the roots would be 3 and -12. Okay, one more example like this. So let's set up our factors, x and x. We need two numbers that, add to -11, multiply to 24. So let's list the factor pairs of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So which of those could somehow make -11? And keep in mind we might need to use negatives. So you could test them out and we could find that we can make -11 out of 3 and 8 if we make them both negative. So -3 minus 8 gives us -11. So they both need to be negative in this case. So we would put -3 and -8 in our factors. We're now in factored form, so we're done. And then we can read off the roots by flipping the signs. So the roots would be a +3 and a +8. All right, so that's the basics of factoring. That's going from general form to factored form. Sometimes, though, we might want to go from vertex form to factored form. And to do this, we're going to convert to general first, like we were doing last lesson. And then we can factor. So we might remember from last lesson that to turn this into general form, we expand that exponent, so x plus 1 times x plus 1. We still have -9. Then we do first, outer, inner, last. So first, outer, inner, last. That's going to give us x squared plus 1x plus 1x plus 1, and then -9. And then we can combine our like terms. This is all from last lesson. And we get x squared, x plus x is 2x, 1 plus -9 is -8. So now from here, we're going to factor. So I set up the factors x and x. We need to add to 2, multiply to 8. So let's list our factor pairs of 8. We have 1 and 8, 2 and 4. Which of those could make 2? We can get it out of 2 and 4, right? A +4 minus 2 is 2. So in our factors, we need a +4 and a -2. All right, and then the roots of this function are going to be a -4 and a +2. We flip the signs. All right, let's do one more like that. So our first step is going to be to expand that exponent, so x minus 7 times itself, and we still have -25. Then we can do FOIL, so first, outer, inner, last, to multiply those together. That gives us x times x is x squared, x times -7, -7 times x, -7 times -7 is +49. Be careful with that. And then we still have -25 at the end. All right, combine our like terms, just like from last lesson. So we end up with x squared -7x minus 7x is -14x. And then 49 minus 25 is +24. And now finally we can factor. So set up the factors x and x. We need to add to minus 14 and multiply to 24. So let's list the factors of 24. 1 and 24, 2 and 12, they're the same as was over here. 3 and 8, 4 and 6. We want to make minus 14, and we can do it with 2 and 12 if we make them both negative, right? So if I have a negative 2 and a negative 12, when I combine them, I'll get a minus 14. So we are done. We're in factored form, and we can finally say that the roots are a positive 2 and a positive 12. Remember to flip the signs for the roots. All right, so that is how you convert quadratic functions to factored form.